Okay, let's give you guys an exercise. So imagine you've got a pizza of radius 10. So from here to here, it is 10. You're going to slice this into 3 pieces. Where must A be in order for the 3 slices to be of the same area? So you've got 1 slice, 2, 3. Where must A be in such a way that all these 3 slices will have the same area? So press pause and have a go. Okay, so to do this, start out with your equation of a circle, which is given by this. Rearrange it to make y the subject. So when you square root it, you will have a positive version and a negative version. The positive version is this, and the negative version is this thing here. We don't care about the negative version, so let's just concentrate on this strand. So now set up your equation. So if you integrate it from 0 to a, so if you integrate it from 0 to a, this block here will give you this area here. Because it's symmetrical, a and minus a, then you can multiply by 4. So when you multiply by 4, 1, 2, 3, 4. So this whole thing here represents this slice. And then for this one here, well, for this one here, integrate it from a to 10, from a to 10. So this thing here would represent this slice. Multiply by 2, it will then give you the whole slice. So you want to search for an A in such a way that that this equals this thing here. So our job is to find A. So now it's really a matter of us trying to integrate this. Now this is quite hard to integrate because if you have an x here, then this will be easy to integrate because this is a derivative of x squared. So for example, if you have something like x to the power 3 square root and then 100 minus x to the power 4, because this is a derivative of this near enough, then you know it's easy to integrate. But this thing here, we don't have the luxury of this x here. So we don't have this luxury of this x here. So we know it's going to be hard to integrate. If you have an x here, then it would be easy to integrate. But we don't have an x here, so we've got to use trigonometric substitution in order to integrate it. So to integrate this, so let's just concentrate on this only. Later on, we can take care of the 4. Later on, we can take care of the from a to 10. At the moment, we're just doing it from 0 to a. So from 0 to a. Let's just concentrate on this block. Let's try and integrate this. Later on, we can take care of these. Okay, so for the time being, let's just concentrate on this bit here. So to integrate this, create a triangle in such a way that this thing here will be true. So if you make the opposite to be x and the hypotenuse to be 10, then the adjacent will have no choice but to be this thing here, So now, so to integrate this, we need to extract the dx. So looking at this, if you consider sine the angle is opposite over hypotenuse, So from here, times both sides by 10. That will then give us this. Remember, we need to extract the dx. So from here, differentiate both sides. So if you differentiate this, you will get this. Differentiate this, you will get dx. So now we can put this into the dx. And this complicated thing, well, if you look at your diagram, if you consider cos the angle equals that square root thing, 100 minus x squared over hypotenuse, which is 10, over 10 times both sides by 10, that will then give you this. So this complicated thing here is exactly the same as this. So now we can put this into this square root thing, and then this dx thing, we can put it into the dx. So this whole thing here will then become this. Remember, remember up here we are integrating from 0 to a. So that's from, this is us integrating with respect to x. So from 0 to a. But then because we use this technique, we substitute everything in terms of theta. So now we are working in the d theta world. So later on we need to convert all these thetas back into x. Because what you've got here, if you look at your original pizza, you're integrating with respect to dx, so you're moving along like this. But now we are working in terms of d theta. We are now working in terms of this. So later on we need to convert all the thetas back into the x, and then we can integrate it from 0 to a. I hope you, well, we've done this many times, so I'm expecting you to understand that. So now this is a constant, so we can take it out. That will then give us this. And then cos times cos, that will be cos squared. So now it's just a matter of integrating cos squared. So integrating cos squared. So cos squared is this thing here, which you've seen many times. We can put this into here. That will then give you this. So now this thing would be easy to integrate. Integrate this, that will be theta over 2. Integrate this, that will then give you this. Now, so we've integrated it, but the thing is, we don't want things in terms of theta. We want it in terms of x. So now we need to translate everything into x. So this sine 2 theta, we're going to have to use this. We can put this into here, and the reason why we're doing that is because we can now, because here you've got double the angle, which is really hard to work with. So here you've got one angle here, so we can easily translate these two blocks. This one here, you've got double the angle there, which is hard to translate. So convert this into this. Don't forget you've got a 2 here and a 4 here. So combining the 2 will then give you this half here. By the way, this whole thing here becomes this. So now we can translate. What is sine theta? Sine is this thing here. Sine is actually x over 2. X over 10. So this sine block here is actually, because look, sine theta equals x over 10. So x over 10. So that block there becomes sine theta becomes x over 10. What is cos theta? Cos is this thing here. Cos is adjacent over hypotenuse. Adjacent over hypotenuse. So that becomes that. And then what is theta? Well, if you look at this, sine theta equals opposite over hypotenuse. Opposite over hypotenuse. So if you want the angle, then inverse sine. So theta equals inverse sine x over 10. So we can put this block into here. So this thing here will then become this. So from here, that will then take us to here. Notice that here everything is in terms of x. There's no theta there. So now we can just work in terms of 0 to a. In terms of 0 to a. So that will then take us to here. And then now you can actually factor out the half here. You can actually factor out the half. That will then give you 50. So now we know how to integrate it. So hang on. So let's go back to the very beginning of the question. We were trying to work this out. We now know how to integrate this. We just worked this out. To integrate this, it gives you this thing here, which we've just worked out. It gives you this thing here. So if you're integrating from 0 to a, then it would be this. So hang on. So going back to the original question, we now know how to integrate this. So this should be easy. So we just switch the a to the 10 around. So hang on. So let me just remind you. Hang on. Let me just remind you. This thing here is this area here times 4. That would represent this whole thing here. Remember, this thing here represents this area here times 2. That would represent this. So just bear in mind that we know how to integrate this now. So we can put it into here. So so this thing here would then become this thing here, from 0 to A, from 0 to A, and then this thing here will become this, from A to 10, from A to 10. Okay, and then let me think, and then these two would cancel each other out, and then this 4 here would then become a 2. So so this whole thing here will then become this thing here. So now if you look at this, hang on, if you put the A into here, and the A into here, and into here, so that would then become, well, if you put the A into here, that would then give you this. Put the A into here, that would then give you this. And then don't forget, you've got a minus, and then you put this into here, and put 0 into here. But the inverse sign of 0 over 10, inverse sign of 0 over 10 is actually 0. So when you put 0 into here, this whole block here disappears. And then if you put 0 into here, you've got 0 times something here. It's going to be, the whole thing would be 0. So it's pointless putting 0 in here. So so this whole thing here will then become this. So now on the right hand side, if you put a 10 into here, that will be 10 over 10, which is which will then give you this thing here. Put a 10 into here, put a 10 into here. Don't forget, 10 squared is 100. 100 take away 100, that will be 0. If you put a 10 into here, this whole block here will be gone, because you got a square root of 0 in here. So so that would disappear, and then you take away, and then you put the A into here. That will then give you this block, and then you take away, put the A into here, and then into here. That will then give you this block. So so from here, that will then take you to here. Okay, so we are now currently here. So hang on, let me just move it across slightly. Bear with me. Let me just move it across. Okay, so we are currently here. We are currently here. So now multiply this times this times this. That will then give you this. And then if you notice this block here, if you notice that this block here is exactly the same as this block here. So when you have two of exactly the same thing, if you add this block to both sides, you're going to get 3 of exactly the same block. 3 exactly the same block. And then if you look at this block here is exactly the same as this block here. So in your mind, add this block to both sides. So if you have 2 of exactly the same thing, and then you add exactly the same thing, you're going to have 3 lots of exactly the same thing. 3 lots of exactly the same thing. And then this block here, well, inverse sine of 1. What is the inverse sine of 1? If you look at the sine graph, it looks like this. 1 is here, so inverse sine of 1 is pi over 2. So this block here is this thing here. Okay, so we are now currently here. So now let's just tidy this up. Times everything by 2. That will then take you to here. So now it's just a matter of us trying to solve this equation here. Remember, we are looking for A. We are trying to seek A. But the thing is, we don't have an elegant algebraic way of working this out. So we are going to, in a way, cheat and do it numerically. So we are just going to get a graph plotter, and plot this line, which turns out to be this red line here. And then get a graph plotter and plot pi. That will then give you this. So the intersection of the two, so this is your A here. So I don't know if you can see it, but it's 2.649. So what that means is A is 2.649. So what that means is if you have a piece of radius 10, then if you cut it at 2.649 and minus 2.649, then the three areas here will be the same. Okay?